Hi there, in this video I'm going to show you the top data exploration techniques, and these techniques will help you to do better data preparation and transformation, which eventually is going to help you develop better machine learning models. If you like this video, please do consider subscribing it. So first of all, let us look at the problem. So our problem is related to churn prediction for a telecommunication company. And here we have some data related to these customers for this telecommunication company. So this data has information such as what is the contract of the customer. It has got information related to the different services this customer has, as well as it has also got information related to the charges as well as the demographics, and also what is the tenure of this customer. So tenure is how many months the customer is with the telecommunication company. Now, our objective is to develop a machine learning model which is going to help us predict the churn based on all these other features. But before we develop this machine learning model, it is important to do a good data exploration, and this will help us eventually to understand the data better, do data preparation in a better way, which will help us ensure that the machine learning model which is trained will have good quality. So let us look into this top 12 data exploration techniques which is going to help us come to a better machine learning model. So the first important thing is to do is the target analysis, which is to analyze how many customers have churn versus not churn. So here we can see that the customers who have not churn to churn ratio is almost about 75 to 25%. Yes, this is an imbalance set, but it is not that critical and we can live with this. Next is to analyze missing values. Missing values are a curse for any machine learning model, and fortunately here we do not have any missing values. Next is to see what are the numerical features and analyze these numerical features. So here we can see that there are 4 numerical features: total charges, monthly charges, tenure, and senior citizenship. And it would be useful to analyze if there are any records which has got 0 value. So here you can see that total charges have almost about 0.16% of 0 values, and this seems to be an outlier because no customer is going to pay 0 charges to the telecommunication company. In addition, we also see that for senior citizenship there is a lot of skewness, so it would be useful to apply some transformations to remove this skew. Now we can do a similar analysis for categorical data. So here we have a lot of categorical fields, and it would be useful to see what are the unique values. So here if you see lots of unique values, in that case you might need to consider some special treatment for this categorical feature. But fortunately here the unique values are not too many, so we can live with it. But you can observe that for phone service you have 90% of the time the most common value is yes. So it means that most of the customers have phone service, and it may not be very useful to take this feature for target prediction because most of the customers are having phone service and it is not going to decide if a customer is going to churn or not. Now the next analysis what we can do is to analyze a correlation. So here, for example, we can see that there is a very high correlation between the total charges and tenure, which is normal because more tenure you have, more will be the total charges. So it would make sense to remove one of this feature, which is going to help us simplify the model, and simplified models always leads to a better accuracy. Now let us see next, which is the feature importance analysis, which is the feature target correlation. So here we can see that tenure and total charges are negatively correlated, which means that less is the tenure, there is a higher probability that customer is going to churn. And you can also see that tenure is more important than the total charges. So we had this question that we have to remove either total charges or tenure because they were highly correlated. And now this helps us to see on which one to remove. So it's very clear that as tenure is more important than total charges, we can keep the tenure and then remove the total charges. Okay, so let us now see the next one, which is the distribution analysis. So distribution analysis tries to understand what is the distribution of data, and then it recommends some transformation which can be applied. So for example, here we can see that senior citizenship or senior citizen has got a very high skewness, so it would make sense to apply logarithmic transformation. But for rest of the features, we can just apply the standard scalar. Now, let us also analyze the feature engineering opportunities. So, for example, here we can see that it would make sense to come out with some creative features, and as an example is monthly charges into a tenure, and this is an interaction feature, and this could be very interesting because monthly charges into tenure kind of also shows on what is the value a customer is bringing to the telecommunication company, and maybe this could be also having an impact on the churn. In addition, you can also have some of the features binned. For example, tenure is in months, so you can create some bins like tenure between 0 and 3 months, 3 and 6 months, 6 months and 12 months, and so on and so forth. Now, let us also look into the outlier analysis. So yes, there are some outliers in the senior citizen field, so it would be useful to delete these outliers. Now, the next one is understanding the class separation. It means that which field is helping us to differentiate between the churners and non-churners. So tenure is a very important field. Total charge is also a very important field. So it makes sense to have them in the model, and it is going to help us understand on what are the features which are causing the churn, and it is also going to help us in the model explainability. Now, of course, you saw all these features one by one, but you can also have a textual explanation of all these features, and basically this helps us to understand in a rapid way on what are the important data transformations and data explorations which needs to be done, and which will help us develop better machine learning models.